Okay, let's have a start. Oh. Could you move that maybe to the left? And let me turn the light off. Yeah, that's good. Okay, that's good. Alright. Let's have a look at those questions. Did you get to try them? I hope so. Did you try these, Siba? Kim? Matt? Good, okay. Andek?
Some.
How many some?
1 and 2.
It's certainly some. Chow? Okay. Do you not want to work for physics anymore? Have you given up on physics and working for physics? Is this what's happening? Alright. 2 electrons are a distance of 0.09 nanometers from 4 protons. Find the force. Okay. So you have 2 electrons and you have 4 protons. And so the force would be 1 over 4 pi epsilon 0. You know this. This is on your calculator. Q1, Q2. So Q1 is 2e and Q2 is 4e. Yeah? And the distance? What's the distance? 0.09 times 10 to the minus 9 squared. Okay. Could you type that in? Let's see what you get. You got your calculator? Yeah. You got an answer, Matt? You didn't get an answer?
I got an answer, but I think I
How could you? What different way did you do it? Yeah, it's the same. But this is the K. That's the same as K. Yeah, that's fine. That's fine. So you could use. What's K? 8.99, is it? 10 to the 9. Okay. So what answer do we have here? Do you not have these constants on your calculator, Siva? No, they're not built in. Are they built into yours? No. Matt, are they built into yours? Andek, are the constants built into your calculator? I know they are on Chow's one. On your calculator, Chow, you have the constants on it. Can you open the lid? Yeah. So, which number is this one? If you can see it.
32.
32, okay. And then which number is this one? The E.
E is 23.
23, okay. So let's type this in. Okay, so it's 1 over 4 pi, how do I do constants here? Shift 7, isn't it? And you said this one is 32? Yeah, 32.
Yeah.
And then another fraction, 2,
23.
yeah, 23. And then squared. Ah, what did I mistype? Or maybe it doesn't like the way I wrote it at the top here. Did you get that? 2.28 times 10 to the minus 7 newtons. What's that? 227 nanonewtons, isn't it? Nanonewtons. Okay. Next one. Do you need a minute to write this down, or is it okay? It's okay? Yeah. Yeah? Yeah? Okay. Next one, number 2. An electron is orbiting 2 protons. What is the velocity? Okay, so you have an electron and it's orbiting 2 protons. What's the velocity? So it's circular motion. The formula is V equals omega r. But the problem is you don't know the omega. There is another formula you could use that says A equals V squared over r. Now, that one actually is a little bit more helpful, because what you can do is you can multiply by m, and then you get F equals mv squared over r. But you know what F is from Coulomb. So Coulomb said the F is 1 over 4 pi epsilon 0 Q1 Q2 r squared. That should equal mv squared over r. So what you can do here nicely is you can cancel this with this. So you can get Q1 Q2 over 4 pi epsilon 0 m or square root. That would be the V. Yeah? Is that okay? So let's type it in. Okay. Square root, fraction. What's the Q1? Let's just say Q1, Q2. It's an E and a 2E. So that's an E and a 2E. And then that's over 4 pi epsilon 0. Now, which mass is it? The mass of what? Is it the mass of the electron or the 2 protons? The electron, yeah. And the radius is 10 power minus 10, isn't it? So the V is pretty big. It's 2251 kilometers per second. I like writing it as kilometers per second because it helps you feel how fast it's going. Because obviously 2,000 kilometers is a big distance. Like, I mean, that's probably how far away some of your home countries are. I don't know. No? Further than 2,000? Less than 2,000? Is it 7,000 to Malaysia? Okay.
I usually look at the plane's screen.
Yeah, it says 7,000. Okay, so you can appreciate how fast this is because it can get to Malaysia in 3 seconds. It's just a pity that it's stuck around the proton, but it's going very fast. Okay, so like I said, you don't have to use kilometers, but for me it really get a good feeling for its speed. Okay. Can I look at the next one now? Yeah. An electron is trapped in an orbit around a proton. How much energy is required to free it? This is the ionization energy from chemistry, isn't it? So in this story here, you have a proton and you have an electron here, and you want to free the electron, and this is called ionization energy. So here's the electron, it's moving with some speed v, and then I say we free it, so free, and now it's moving away, and I said in the question you can assume it's the same speed v. And my question is, how much energy do we need to do that? So if you look at it here, what energy does it have here? It has kinetic. And what else does it have? Potential. Now, here's the important thing. Because it's trapped, the potential is negative. Remember? Because it's trapped. So it's a minus. And the formula, I gave it to you. It's a Q1, Q2 over 4 pi epsilon 0 or. No or squared. And that should equal, now, what energy does it have here? What is it? Just kinetic, isn't it? Now there's a small problem here. You can see that this equation doesn't make sense, does it? That means the electron can't just jump off by itself. So what must have happened is somebody must have given it some energy to be freed. So somebody put some energy in here. I'll call that energy E. So here I need to imagine like somebody comes along and they do a plus E. This and this cancel, so you get E equals that. Now if you wanted to just skip that step and at the very beginning just say the energy needed to be free is potential energy, that's fine. Because remember, that's what I explained the meaning of negative potential energy was. If the potential energy is minus some number, then that's how much energy you need to give it to free. Okay? So you don't need to write it like this, I just thought I'd show you. So the energy to free it is just this. Okay, let's type that in. Now, because that energy is so small, what would be an appropriate unit to use? Electron volts, yeah. So that's 14.4 electron volts. That's how much energy you would need to give it to free it. That's the ionization energy. Yeah? Yeah. Okay, next one now. A proton is fired at speed v towards 3 protons as the electron... Oh, so that's a mistake, I'm sorry. You should have said an electron is fired. An electron is fired towards 3 protons. As the electron approaches the protons, it feels a repulsive force. What is the value of v if the closest the proton gets to each... The closest the proton... Oh, for goodness sake. Sorry, I was right the first time. A proton is fired towards 3 protons. As the proton approaches... Sorry, everything's a proton. Everything's a proton. So you have 3 protons here. And you have 1 proton here, and what happens is this gets fired, it gets closer and closer, but then it starts to get pushed back by the 3 protons, doesn't it? And at some point it stops, and then it starts to head back. And this distance here is 1 nanometer. And my question is, what's the V here? Now, what energy does the proton here have? It's only kinetic energy. Yeah? What energy does the proton here have? Right here at this exact moment. Yeah, see, it's not moving, is it? It's stopped. That's potential. Is it trapped or not trapped? What do we think? I see you thinking deeply about this. You think it's not trapped. That's correct. So it's not trapped because it's about ready to spring out. Okay? So that means the potential energy is a positive. Positive. 1 over 4 pi epsilon 0 Q1 Q2 over R. So it's the energy here equals the energy here. A half mass of the proton V squared equals 1 over 4 pi epsilon 0 E 3E and a nanometer, no squared. So let me see. I should bring this one down. I should bring this one up, and then I should square root it. And I have my answer. Let's see what we get. Mm, 23. 23. No. 23. Okay. Okay. 91 kilometers per second, we'll say. 91 kilometers per second. Yeah? Is that okay, Matt? Yeah. Can I do the last one, Siba? Okay, 5. An electron orbits a proton as shown. How long will it take the electron to complete one orbit? So you have a proton, you have an electron, and I want to know the time here. So you know the formula T equals 2 pi over omega. But the problem is you don't know omega, do you? But you know that F equals m omega squared R. So that means omega is root F over mr. Yeah? So that's good. That means T is 2 pi root mr over F. Do we know 2? Yes, pi, yes, m, yes, or, yes, F, no. Okay, so we can say T is 2 pi. Is that you, Kim? Important call? Alarm to wake you up at 9:25. Okay. This is why you're late to class. Okay, that's m or over 1 over 4 pi epsilon 0 q1 q2 over r squared. Yeah? So let's just put that in. 2 pi root fraction mass of the proton times the radius, another fraction, Q1, Q2 over 4 pi epsilon 0 or squared. Right, I got a tiny time. I think I did everything okay. Yeah. Oh no, no, something's wrong. Sorry. That is wrong. Huh? Is it? Oh. Hang on, I'll put a... Okay. I just use a bracket. Yeah, no, it's right. 1.69 times 10 to the minus 14. Okay. Yeah?
In number 4,
Yeah?
how do we know it's 3E?
Ah, read carefully. A proton is fired towards 3 protons. Can you show him, Mandek?
Protons by speed towards 3 protons.
I wrote the word 3 instead of the number 3. Okay. Are you writing this down? You're done? Matt? Problem? No problem? Like, can I close this? Yes? No? I can close it? Not close it?
Yeah.
I can close it? Are you sure? You're not sure. Tell me what you're thinking.
No.
No, you don't want to tell me? Okay. Did I make a mistake? I could have made a mistake. Okay, alright, okay. Okay.